She Talks attendees. Thanks for joining the session on Secret Sync across multi-cloud environments. We are taking on a journey to explore how HashiCorp Vault, specifically the Enterprise Edition, empowers seamless secret synchronization across diverse cloud landscapes. In a world where multi-cloud environments are becoming the norm, securing and managing secrets consistently poses unique challenges. So buckle up for an interesting journey on Vault Enterprise, where we'll look at key challenges and the work through the solution for multi-cloud environments. Let's get started. I'm Aditya Sharma, and I'm thrilled to be here with you today. As a DevOps team lead at Arctic, we are a boutique consulting firm based out of Toronto. My journey in the DevOps and cloud architecture space has been one of the continuous learning and innovation. I'm excited to explore one of the newest features, Vault Enterprise Secret Sync, with you all. We'll start with a high-level view of the secrets management landscape. Then we'll look at what challenges do organizations face, because multi-cloud environments bring unique challenges, and why is it crucial to have a sync solution in place. This segment sets the stage for a deep dive. Then we zoom in on Vault Enterprise and its secret sync capabilities, and how does it address these challenges. We will then deep dive into strategies for synchronizing secrets across cloud providers like AWS, Azure, and GCP. And we will uncover some key concepts. Then, the moment we all look forward to, a demo. Watch as we put theory into action, showcasing how Vault Enterprise synchronizes them. This agenda is designed to take you on a journey from macro view of secrets management to the nitty-gritties of Vault Enterprise secret sync capabilities. Let's dive in. Let's start with the basic fundamental question. What is secrets management? Secret management refers to the practice of securely storing, retrieving, and managing sensitive information, often referred to as secrets, within an organization's infrastructure. Secrets can include credentials, which are required to access various cloud platforms like AWS, Azure, GCP, or encryption keys, API keys, tokens to enable service-to-service communication, or passwords for the security of critical data stored in the database, or any such type of sensitive data that is crucial for security of applications and systems. So, inherently securing the secrets is paramount importance that companies across the globe recognize and implement. One important thing to note is that secrets are unlike traditional credentials because they are leveraged not only by human users, that is developers, DevOps teams, cloud squad, etc., but also at the same time by the applications, the services, the infrastructure, the platforms to establish trusted identities. So it becomes obvious that these secrets must be managed securely and as much as possible centrally, so that their life cycle like creation, updation, deletion, etc. can be effectively managed. The popular solution for secrets management in this space includes HashiCorp Vault, which provides fully centralized capabilities to manage the secrets. At the same time, the cloud providers like Azure, AWS, and GCP provide services like Key Vault for Azure and AWS and GCP Secrets Manager. It provides cloud-native facilities to integrate respective platform services natively. Now, what are the multi-cloud challenges when the companies adopt multiple clouds? They embrace this multi-cloud strategy, and they often turn to native secrets management solutions provided by each cloud provider. It may be primarily due to convenience initially to get started, or if the organization does not have enterprise-wide secret management strategy, it is quite obvious to choose cloud-native solutions for secrets management. The cloud squad teams who are managing the cloud, designing the landing zone, they design it in such a way that when application teams onboard, the runbooks available to onboard the teams usually have cloud-native secrets management built in. But good so far, no challenges there. Now enters the HashiCorp Vault because security teams have agreed on an enterprise-wide secrets management strategy. As a unified secret management solution, it liberates application teams from multi-cloud native solutions. But as good as it may seem to security teams, application teams have fully adopted the native secrets management solutions. Any shift in infrastructure or adoption of new cloud or a solution necessitates the complete overhaul of their existing process. The introduction of Vault is a disruption in their usual workflow. The application teams are so tightly coupled to unique features, APIs, workflows of each cloud provider secret management solution that they have to learn new Vault integrations, update their workflows, and with less time and resource, this leads to friction between application and security teams. This rift of cloud native versus centralized control requires a mutually beneficial solution which can help security teams implement security successfully in Vault, whereas at the same time, the application teams don't have to change their workflows and they can continue to consume secrets from existing implementations. In a nutshell, if I have to summarize those challenges, security teams are aiming for increased security across clouds and machines. They need a mechanism to get insight into when secrets are modified or accessed with advanced filtering and centralized capabilities. Cloud teams are managing cloud native solutions and would have to work with security teams and developers to migrate the secret management posture in Vault. The development teams lose their productivity in attempt to improve their security posture. Their workflows are designed to track down secrets from fragmented locations in cloud providers. They would need certain mechanism where they can improve the security posture without spending additional time and effort. The answer to all these challenges is Vault Enterprise Secret Sync. Now let's look in detail what it is. This is one of the latest features in HashiCorp Vault, which enabled organizations with multi-cloud presence to leverage Vault to consolidate credentials, manage secret sprawl, and automate secrets policies centrally. It allows users to synchronize secrets when and where they require them, and to continually sync secrets from Vault Enterprise to external secrets manager so that they are always up to date. It is part of Vault Enterprise solution only. It is a solution that maintains one-way sync for KV-V2 secrets into various destinations that are easier to access based on client needs. Doing that, Vault can maintain to remain a centralized system of records, but can cache a subset of secrets on external systems to enable last mile delivery for developers. Secret Sync on Vault Enterprise is available as a beta feature in 1.15 release. The beta release of Vault Enterprise Secret Sync covers certain selective yet most common destination for secrets like AWS Secrets Manager, GCP Secrets Manager, Azure Key Vault, and GitHub Secrets as well. Now, what makes the Enterprise Secret Sync so powerful is due to three key components or configurations that we need to provision in order for sync to work. Let's start with the heart of it all, secrets, which we have been talking about. In our context, we are focusing on HashiCorp Vault's KV version 2 secrets only. So it can contain any sensitive bit of information that needs securage and seamless synchronization. It can be API tokens, normal passwords, credentials to access machines, etc. Now consider the diverse landscape of multi-cloud environments. Each cloud provider offers its native secrets management solution. These are called destination. So when we say the AWS Secret Manager or GCP Secret Manager, those are essentially a destination or a placeholder where the secrets will be synchronized from Vault into that. Currently, there are 5 destinations that are supported, and in terms of major cloud providers, it is AWS, Azure, and GCP. and in addition, it can do GitHub registry secrets as well. the magic happens in the association. This is the third object, which is the glue. These are the configurations that tie secrets into respective destinations. The configurations here are the rules guiding the synchronized flow of secrets. The associations are granular, and each secret has an association. So one secret tied with the destination becomes one association. Many associations can actually share a destination. Secrets, associations, and destinations. These three key concepts in Secret Sync are centrally provisioned in HashiCorp Vault, and each destination can have any number of secret associations tied to it. That means you can have as many secrets synced into any number of destinations using these three objects. Now, the only configuration needed in the cloud platform is user access with appropriate privileges for cloud native secret manager service. Once they are configured in Vault, the association automatically takes care of complete lifecycle of secrets, which we will look in the demo. Now, let's look at some commands to create the objects that we looked in the previous slide. So for secrets, first we have to enable secret engine in KVV2, then add secrets in the path. Now, depending on the destination, whether it is AWS, GCP, or Azure, we would need to ensure that the appropriate access to Secret Manager service is available for user account or service account. We will configure that AWS user account along with appropriate region to configure the destination. So we define the destination for AWS here in this example, and we provide the access key and the secret access key, which has ability to write secrets in the Secrets Manager. So this provisions our destination. Now, most importantly, we have to create an association which allow Vault to manage sync and secret lifecycle centrally. In this step, we need to associate secrets which are managed with the appropriate destination. One secret can be associated with multiple destinations. Same secret can be associated with multiple regions within a cloud provider or even across multiple cloud providers. Now, as a secret that is associated from Vault KV2 secret engine into external destination, it is managed actively by a continuous process. If secret is updated in Vault, the secret is updated in destination as well. If secret is deleted from Vault, it will be deleted from external system or destination as well. This process maintains several sync statuses which relay information about how the latest sync operation has occurred. Syncing a secret into one of the external system is done by creating a connection between secret and a destination called association. The whole status information of whether the sync has occurred, what has changed in Vault, and what has synchronized in destination is tracked in the association object. This object tracks the secret's current sync status, the timestamp, the error code of any sync that has occurred. And as you can see here, the application source code will not be aware of Vault and will continue to access the secret using the same workflow which was implemented with the cloud native solution. Now, let's look at the demo. So this demo will showcase how Vault Enterprise Secret Sync will automatically sync secrets between Vault and Google GCP Secrets Manager, so that developers do not have to change their workflow to consume secrets from Vault. So operators can still leverage the power of Vault Enterprise for secret lifecycle management, but developers can consume the secrets through platform native tools and technologies. Let's look at the demo. So as you can see here, I am an admin in GCP. We have to create a service account. Let's give it a name, Secret Sync SA. So it's always a best practice to describe what the service account is for. Once we have given that description, let's create and continue. This step would require us to provision that user with certain role. In this case, it is secret manager. You can give custom permissions as recommended in the documentation, or the selective roles. I'm giving the secret manager admin. Let's continue. Click again and we'll create it. So this service account has been created, secret sync. We have to create a key so that we can use it from outside, from Vault, to push the configurations. So we have got the key, the JSON file for the service account. Let's look at creating the objects we discussed in the slides. So first thing we have to create is a destination. So here you will see we are creating a destination. The type is GCP-SM secret manager. We are naming it team1-destination. And we will provide the service account credential that we got. This is the same service account which can access GCP Secrets Manager. So we have created the destination that would allow us to write secrets. But there are two more objects that we have to create. So if we try to read it, this destination is successfully created. Now the other two objects, the first thing is secret. Now we have to add a KVV2 secrets engine. We enable that and we would add a secret to that secret engine. Once we add that secret, this puts two things in place, destination and the secret that we have created here, where we have provided API key and key ID. The last and most important thing is association. So as you will see here, we are tying the destination GCP SM team1 dest, and we are creating an association. We have to tie it with the secret as well. So we have to provide the KV mount path and the secret name. So association is granular, which means each secret will be tied to a destination. You can create as many associations as required. So this creates an association, which means automatically in GCP, the secret should be synced. And as I just refreshed, this secret has automatically been synced here. If you look at the value, the API key and the key ID has been updated here. One thing to note, you have to enable the API for Secret Manager if you're using it for the first time. Now let's look at the life cycle of secrets. What happens if we modify a secret value? So for the same secret, we have updated the key ID. It should automatically be reflected in GCP Secrets Manager. So let's wait for few seconds. It's automatically replicated. As you would see, it is saying it is out of date. So refresh it and the next version is automatically available now. And the key ID updated is available in the GCP Secret Manager. So we are centrally managing the secrets in Vault, whereas the secret sync is actively replicating it in the GCP Secret Manager. Now, if you don't want to manage, this is the deletion. So we have seen the create and update. If you don't want to manage the secret anymore, we can delete the association, and that would stop that replication into the Secret Manager. So once we do that, the association has been deleted. Let's wait for a couple of seconds. It would automatically delete the secret and all the versions that are available right here. So if we look at it, it would refresh and the secret is gone. So that was a demo on how by creating secrets, associations, and other objects, we can actually manage the automatic replication. So secret provisioning in Vault. So let's look at, so we looked at GCP Secret Manager, but how about Azure and AWS? So secret provisioning in Vault remains the same, irrespective of the cloud provider. The difference lies in the way AWS and Azure destinations are provisioned. Once the user permissions are configured in respective cloud environments, type of destination with each of the cloud provider, is provided to configure destination. So as you would see here, we are providing AWS SM. In the demo, we provided GCP-SM. These are the type of destinations that are predefined. So in this, we are passing the secret access, AWS access key and secret access key. So this is the account which has Secret Manager permissions to write, update, and delete the secrets. For Azure, it will be Azure KV because it is Key Vault. So parameter passed in the configs to configure destination depends on how user account will access Secret Manager or Key Vault in the respective cloud environment. It can be access keys, service accounts, or principal in Azure. In terms of associations, there is not a lot of difference in the way it is configured for other cloud providers. Secrets, it is essentially the same. Destinations are about similar configurations because they are kind of a glue which ties secrets back with destination. So depending on the destination for AWS or Azure, that is the only thing that changes here. The name of that. Rest, the way it is provisioned, remains the same. So we have seen how Vault Enterprise Secret Sync can help to remediate secret sprawl and how organizations can establish centralized secret lifecycle management in a single control plane. The organizations are interested in leveraging the power of secrets management with Vault, but access them in a platform native way. So Secret Sync allows developers to focus on their pre-existing platforms and reduce effort for an organization to adopt HashiCorp Vault. So it is not only preserved developer productivity, but it also improves Vault adoption as a centralized secret management solution. By achieving these goals, organizations will not only strengthen their security practices, but also create an environment that fosters innovation and efficiency among the key teams. Having said that, as I wrap up this session at HashiTalks, I want to extend my heartfelt gratitude to each and every one of you. Thank you for being part of this engaging and insightful event. If you have any thoughts, questions, or suggestions on this talk or topic, please feel free to reach out. My LinkedIn handle is on the screen. Once again, thank you for your time, engagement, and passion for advancing in the world of HashiCorp. Have a great rest of the day.